Read the question. I think this V naught, I'll slightly adjust it. If not given properly. It should be like this. Read the question, getting into this one. It was supposed to be launched into a circular orbit, but due to some reasons, what happened, it was launched at an angle alpha. Then it will describe the elliptical orbit that R max and R minimum are to be determined. That was the question that was asked here. So he's asking that particular R max and R minimum that have to be determined. What is the expression for the energy of satellite in elliptical orbit? Expression for energy of satellite in elliptical orbit. Recollect some formulas. It becomes very easy if you can remember that data. What is the expression? So first, what is orbital speed? I'll proceed. Problem is very simple. You need not to do anything. GM R naught. If it were in circular orbit, it would have been this much of the orbital speed. Then it was launched at an angle alpha. If I launched horizontally, okay, but at an angle alpha, it is launched here. So therefore, elliptical orbit it will come. So what is the expression for the energy of a satellite in elliptical orbit? That should be equal to minus mass of planet. Yeah. So this should be equal to GMP, mass of the satellite is M, into 2 R naught, no? And what is R naught? This should be the total energy, what it is possessing, that one. And what this should be equal to, this E should be equal to minus G after certain time. So somewhere here it is. Anything? So somewhere here I'll write it. Let it be. At a distance R. Take like this. So this should be equal to what now? GMPM M V square by 2. Then applying the conservation of angular momentum between these points A and B. So this is the energy at A, energy at B. I think it is okay. Then applying conservation of angular momentum between points A and B. What should be the angular momentum there? Should be equal to M V naught R naught cos alpha should be equal to MVR. V and R are unknown. Solving eliminate V, you'll get expression for R. Two equations. Quadratic equation for R will come. Solving that will get the required answer. Fine. So you to ask question like, sir, what is this equation? This is the energy of satellite moving in L2, and total mechanical energy must be considered. And what is the energy when, if it were supposed to move in circular orbit, what was the energy that one? Already we know GM by 2R, and the total mechanical energy must remain constant. This is something related to circular orbit I brought. This is something related to elliptical orbit is what we are bringing. And we know mechanical energy must be considered in elliptical orbit, and angular momentum should be considered. Objective questions, maximum. And this one more. If a planet is suddenly stopped, read the question, get the diagram first. Get the related diagram. how much of time it takes. You can do by two methods, like a just now I discussed the integration method. You can totally avoid integration and you can